In function as a service, we are trying to develop a microservice-based cloud system that emulates AWS Lambda behavior. Here we are using Docker Swarm and its associated services to ensure that we meet all the requirements for a cloud application. Uh, After deploying Docker Swarm, you can see all the nodes that are deployed under it using this command. This is the manager. We are currently deploying the manager, and it has three nodes under it. So Docker Swarm actually does the resource pooling for us by managing all the commodity servers that we have, and it deploys all the microservices that we expect to on one of these nodes and itself to ensure load balancing as well. And we have certain applications from our side to enable the cloud computing application as well. It is deployed on the master node. So the main application that the user would interact is the CC app, which is our API gateway. This is the application that allows users to interact with, and through this application, the user can do on-demand deployment of all his application needs, wherein we use the inputs that the user provides and either create functions, users update them, and execute them based on the parameters that they provide. And as and when the requests come in, we would also ensure rapid elasticity with the help of Docker node, because Docker Swarm would deploy it on nodes and ensure that the load balancing is done through the bin packing algorithm that they use for deployment. And since the Flask app uses REST APIs, a user can use any sort of client to talk to it. There are multiple clients which are available, like the Postman client in Mozilla, and libraries in Java and Python also offer a lot of facilities to develop custom clients. We have demonstrated it with the help of a Python client as well as Postman to show the broad network access aspect that we have brought into this cloud application. The other major components that we have are the DB Manager, which is a Tomcat application hosted in Java, and the actual database is a Postgres DB, which is internally managed through the DB Manager application. We have hosted a registry, Python image registry, which holds all the microservice images, so that which get deployed based on a user demand and are removed once the operation is done, so that we satisfy the microservice architecture that we are intending to demonstrate. Along with these services on the Docker Swarm, we have deployed monitoring services such as C Advisor, which monitors all the operations that are happening, and it stores an Elasticsearch. And we use Kibana to actually display the metrics that we obtain. So this is a sample metric that you can see for the file system usage, network usage, and the containers which are currently running on the particular node, and the memory usage. All these are deployed on the Swarm, and it also demonstrates how the deployment happens on the Swarm. In case of C Advisor, since it runs on all modes, it is deployed as global, whereas Elasticsearch is run on only one node, so that if it goes down, Docker service would actually create the same copy of it on another node to ensure that it is always up and running. So as you can see here, we have a user create operation that the user has triggered, in which case this user container is spawned, a service is spawned on the Swarm, and since we require only one copy of this, we have only deployed one set of this user create. So we can do more. So for viewing the service, you can use Docker Service LS. This shows all the services that are running, and for more details, you can use Docker Service PS on the user create. So this tells us that the current the service is deployed on the manager, and the manager will be executing it. So another demonstration of this is, since the user resources have been exhausted on manager, it has shut down, but the service never goes down, and it gets redeployed on node 2, and the same request gets executed here to show how highly resilient our service is. So as you can see, the service actually got created and completed actually. So the user must be present in the DB right now. So until and unless the operation actually completes, it keeps getting redeployed. And even if the infrastructure is not up to the mark, the Docker Swarm will ensure that the service will always get deployed and completed. The code inside ensures that this is done with 100% accuracy.
Hello, my name is Akhil. I'm going to talk about the execute function flow in our app. This is one of the most core requirements of our project. Uh, Consider we have a sample function for Fibonacci sequence. Uh, in our um, in our format, we can give any function required. We just have to declare the function as global, and we have a MADHat function. This is our function as a service, where anything in MADHat function is executed by us. We allow you to have an input data and an output data. The input data can be any JSON structure. Example like this. You can have anything inside the input data and anything in your output data. So your output data, the data gets modified, or you can create new data once the function is executed. So hence we give the user the opportunity to take in to give in any kind of input data and expect any kind of output data when the function is run. And also we give the opportunity to have multiple nested functions as long as the function has been declared global. Now I'm going to show a walkthrough of how this works. We've already created a particular function in our ThoughtLab DB, which has a function ID described here. Now I'll be sending the post request through our Postman app. I've sent the request. The container has been spawned. The request ID is given here. Our architecture follows a way where we have to poll with the given request ID. As example, this particular diagram illustrates it. A user can access certain request API endpoints. We have 7 request API endpoints. Now I'm explaining execute function. So he can give the required input data through the execute function call. The execute function call then creates a container and gives a request ID back to the user, and the user can poll on this particular request ID. Now let's see if our function has executed. We take this particular request ID. We have another API endpoint called check request status, which allows the user to check if the particular request has completed execution or not. Now, if you look at it, it still says container spawned. Let's wait until this gets completed. Now, if you look at it, after polling the request, now if you have a look at it, the output has returned to us. This is the output text, and this is the output data. The output data is a Fibonacci value 55 and 1 that was mentioned in our execute. If you look at it, the execute data we sent was val 1 and val 9, and this is the function that we gave. So it returned the required fib iterative where required. Hence, the user can take any input data, any output data. Additionally, we have implemented compilation features where when the user creates the function, if there's any compilation issue, we throw back on compilation and do not allow the user to create the function. And any runtime error occurs, we show the same. We show the same in the output text saying that the run has failed and it's compilation error. We have attached screenshots showing the same of runtime exception and compilation exception. Thank you.
Hello everybody, I'll be showing you how the service actually works. So we have created a client for this, which will do different functions like creating user, creating functions, executing functions. So we'll be starting with creating users in bulk. We'll start creating users. So number of users needs to be provided. So we'll create 8 users with a prefix. Goes any prefix. So all the user with this prefix will be created. So there are 8 users been created. This is a request ID to track the specific request, and these containers are used to generate this request. Now we'll create new functions. So in bulk, so for creating functions in bulk, we have to enter number of functions required. So we enter suppose 6, and then enter a prefix for functions. We have to enter a username, so that function associated with the username, and password for authentication. So we have created this function. These containers have been spawned. This is the request ID and related to specific function created. Like we have function here. Okay, so now we'll be executing the function. Function command. So we have to enter the username, password. We already created a function. Number of function to be executed. Next time it's a function will be executed. The function already created a function. Now there'll be a file used to take for arguments. Function. I can see all these functions have been created. Now we can poll all these requests to check the status of this request. So we'll do poll all. We can also enter the request ID, check a specific request. We'll do a poll all, and we can check all the requests that have been done. So here's the execute function request. Container has been spawned for this. Like we can check here, like this execution request has been successful. So we can check here, run was successful. And similarly, like the users we created and the functions we created, we will have status here for those functions also. So we have this create user and user ID has been given and create has been successful. For the functions, we will have a similar thing like once, and these are the function requests. So your function ID is this and function has been created. So in this way, we can poll all the requests, check their status. We can poll a specific request by giving it the ID, and we can do different functions using the client. So